Hey guys, this is Patrick from STH, and today we're going to take a look at the Dell EMC PowerEdge XE8545. Now this server is a dual AMD EPYC 4U server that has a nice little twist that makes it basically the most powerful PowerEdge that you can go purchase today. Specifically, you get a total of 4 NVIDIA SXM4 GPUs. That means that you can get the NVIDIA A100 either in the 40 gig or 80 gig, 400 watt or 500 watt models, and this 4U server can actually cool either of those configurations. And what's also really interesting is the fact that you can actually cool those 500 watt 80 gigabyte NVIDIA A100 GPUs and 280 watt AMD EPYC Milan processors all in this 4U chassis using air, so you don't have to go to liquid cooling. But that's not the only feature that Dell made in this server to really be able to go and I guess get into kind of those enterprise data center racks. They did a couple other things that are really interesting, and we're gonna take a look at that as we go through the hardware. Now, as full disclosure, we are marking this as sponsored just because Dell sent the server so we can go take it apart. These things are super expensive, so we really can't, we don't have the budget to go buy, these servers to go do these reviews. So of course we're gonna go mark this as sponsored. Now, normally when we take a look at server reviews, we kind of go through the hardware and then we go through some of the management stuff, and then we kind of talk about performance, power consumption, then kind of talk about market analysis and final words. But this one, I wanted to, instead of just doing the external and internal hardware overview like we normally do, I want to focus a little bit more on some of the very specific things that Dell did making the server. Frankly, this thing is quite different than a lot of servers that you're going to see today. And it's kind of like, just when you tear apart the server and you kind of look at like what Dell did, you realize, oh my gosh, this is a cool design. But on the other hand, it's also a little bit funky. And if you look at the back edge, you're definitely going to see that little bit of funkiness. And we're going to talk about what that's all about really soon. So let's get into it with our external hardware overview, because I think that's really important on this system. But let's start with the front of the system, and we have a very nice Dell PowerEdge faceplate, and you can get the LCD option there if you want that thing. You don't necessarily need to have it, but it does look cool, so I guess that's what it is. But then behind that, what we actually have is the top view is an array of 10 2.5-inch drives. Below that is just a bunch of fans. Now these are hot swap fan units, and they have to move a ton of air because you're cooling up to 4 NVIDIA A100 500 watt GPUs behind these fans. Now, even though that this is a 4U chassis, what you're gonna notice is that partition between the 1U of 10 drives and then that big cooling section with all of those fans, that actually is going to really, I guess, kind of define how Dell thought about making this server. This is essentially 2 servers that are stuck together. And when we move to the rear of the unit, you're gonna see that, I guess, in a little bit better detail. The first thing you probably will notice is the fact that the top of the server, the top 2U, stick out a little bit further than the bottom 2U on the server. Normally on the back of a server, you see that everything is all basically the same, I guess, depth, but this is one where there are literally 2 different depths depending on if you're on the top or the bottom of the server. That's because this, again, is 2 servers stuck on top of each other. So if we look on the top of that, what you're gonna see is that we have all the IO expansion slots. We also have just kind of our standard server IO. Now this is one of Dell's newest servers, and what you see with their new servers is that they don't necessarily have like hard motherboard IO anymore. Instead, everything is based on expansion or like little changeable PCBs that are field replaceable. So if you want to do customization, for example, on the NIC LOM, or you want to go do something else, you can totally go do that by just swapping out these different components on the rear. There's also a set of risers. However, a lot of those PCIe lanes that would normally go to risers and be available for back or rear IO are actually being used for the GPUs and NVMe drives. We're just going to point out real quick that the primary NIC in this server is actually based on OCP NIC 3.0 form factor, which is super cool. This is definitely Dell adopting one of the biggest technologies in this generation of servers, so it's just kind of cool to see Dell doing that. You're also going to see that we have things on the back, like we have our standard iDRAC out-of-band management port, and then we also have a VGA port. If anybody is thinking like, hey, we have 4 GPUs, let's go use that, VGA connector in the back and let's go play video games or something like that, you're not going to go do that. That's really wired to the display output that's on iDRAC, not necessarily the A100 GPUs. The A100 GPUs are really compute-focused GPUs, so I know somebody's going to put that in the comments, but that really is not how these things work. Now, below that section, you're going to see this other 2U section that's set back a little bit. And in that section, what you're going to see is that there are a total of 4 power supplies. These are hot swap power supply units, and the real goal there is that you have enough power to be able to run this entire system. This is not a system that you can just go put a, say, 2 or 2.2 kilowatt power supply in and expect the thing to work, or even a 2.4 kilowatt power supply and expect that you're going to be able to run it off like one or a pair of those power supplies. You actually do need to go and have multiple power supplies to be able to handle things like a failure. We'll talk about this in a bit, but you're certainly going to budget something more in the kind of like maybe over 2 kilowatts, like well over 2 kilowatts, maybe not necessarily over 3, but like in that 2 to 3 range is really where you're going to operate the server most of the time. So just keeping that, fully above board and make sure everybody's on the same page here. This is not a low power device at all. But when you look at this rear, other than the fact that it looks funky, you may not realize what's really going on here. And let me kind of just bring this back for just 1 second. Now, if you remember the front of the chassis, you had those 1U, that basically 1U of like 10 drive bays, and those on the top, you had 3 U's of fans, and that was kind of on the bottom. And then in the rear, we have basically 2 2U partitions. So the top of the system is actually what kind of runs the CPU complex, your add-in cards, all of your storage, all that kind of stuff runs on the top. The bottom of the system is basically dominated by the cooling and power delivery for the server, specifically for that bottom part, and also the 4 NVIDIA A100 GPUs. The top has its own fans, and that's why this is actually like 2 different servers. It's kind of like a 1U server that exits as a 2U server and a 3U server that exits as a 2U server, all put together into a single 4U server. And that might seem a little bit weird, but on the other hand, you don't necessarily have to have a 3U server and like a 2U server, so that way, that's not how these things are kind of built. You don't need to have 5U for this. It's only a 4U solution, which is not too bad. And then the other side to it is that by stacking this into a 4U solution, not trying to do like a 2U like some other vendors, what you're actually going to see is that Dell was able to maintain a relatively short depth with the system. Specifically, this is listed as only, I think, 810 millimeters deep, which means that it will fit in almost every standard rack. I mean, this isn't like, a over 35-inch system or anything like that. It's actually relatively small, and that means that the vast majority of standard racks are going to be able to fit the system, and that's something that Dell really needs to do because it's really catering to its enterprise customers that have kind of fixed racks that may have been installed in a data center years ago. Okay, so looking inside the system, let's kind of get into some of the hardware details because we've looked at the front, back, the chassis, but let's kind of get into how Dell made this really crazy system. So let's start with the top, and what you're going to see is that we basically have that front hard drive cage or SSD cage on the front of the system and really at the top, and then we have a kind of cover which covers up and kind of keeps that airflow separated between the top and bottom of the system, and then we also have a bunch of cables. Now all these cables are really NVMe cables. You have to remember that all of the NVMe drives get PCIe Gen 4x4, which means that you need a ton of cables to cable that PCIe from the motherboard to the front of the system, and that's why you see a ton of cables here. We're just going to quickly note that although 8 of these are NVMe or PCIe Gen 4 NVMe drives, there are 2 SATA SAS drives as well up front, so it's a 2+8 configuration. Now, just behind that, what you're going to see is that there's a 2U fan partition. So this is the totally crazy bit about it. This is a 4U system, but in the front, you have 3U of fans. Then just behind that, in the middle, for that top section, you have 2U of fans to be able to cool that part. So you get a total of 5U of fans, all compressed into a total of a 4U footprint. Now, behind that fan partition, we see basically something that we've actually already seen before. And what I mean by that is we get a dual AMD EPYC Dell PowerEdge platform, and really the motherboard is behind that. And that motherboard has our 2 AMD EPYC Milan, so 7003 series Milan processors. Each of those processors has 8-channel memory, so it gives you a total of 16 channels of memory there, and then you get a total of 32 DIMMs because you get 2 DIMMs per channel, which gives you 32 DIMMs in your dual socket configuration. You're definitely going to want to put 2 CPUs in the system. I know some people think like, hey, can I get by with 1? You're not going to do that in the system. You're going to have 2. Now those CPUs, because they are the AMD EPYC Milan series, can go up to 280 watts. The system can cool 280 watt CPUs, which is something that I guess lower end systems sometimes can't do. And then the other thing is that you can get a total of 128 cores across the 2 sockets, so 64 cores and 128 threads per socket, which means that you get a total of 128 cores and 256 threads in a server like this. Now, behind that, what you're going to see is just a whole bunch of risers, and there are a little bit of PCIe expansion, but the vast majority of this is really focused on connecting the GPUs as well as connecting the NVMe storage. You do, of course, need high-speed networking, but you're kind of limited by PCIe lanes at some point anyway. But for that, Dell actually has a trick that we already saw on the Dell EMC PowerEdge R7525. We did an entire piece showing how Dell has this flexible motherboard arrangement where they have a couple of lanes that can either be used as a link between the CPUs, or they can be broken out and used as for like PCIe connectivity. Instead of going over this motherboard in great detail, I'd rather just direct you to that review. And then the piece that we did specifically on how this whole reconfigurable PCIe lanes with this AMD EPYC platform. It's something you don't get on the Intel platform, so it's really cool that Dell has this. And we're gonna just kind of link you to those and put those in the description. Now, underneath that front section, we talked about how underneath all those cables, there's an airflow guide. And underneath that airflow guide, what we have is 4 NVIDIA A100 GPUs. Now, this platform is actually called the NVIDIA Redstone platform. So in NVIDIA's hierarchy, you kind of have at the very low end, you have like the PCIe GPUs, and then the 4 GPU configuration, which this is Redstone. The higher end configuration is the HGX A100 or the Delta platform. And so that's kind of the hierarchy, and this is kind of that pretty solid mid-level there. Now, Dell doesn't actually have a Delta platform that they advertise in the PowerEdge line, so they don't really have that 8 NVIDIA A100 platform. We have done reviews recently of an Inspur server that used those 8 A100s. We also did both air-cooled and liquid-cooled 400 watt and 500 watt Supermicro 8 A100 systems just recently, so you can go check out that. We'll link that in the description as well. But the Redstone platform is really designed for a pretty specific use case. It's not necessarily meant for like the highest AI performance, but instead what it is it's designed to really do a lot when it comes to the CPU to GPU communication. Because in Redstone, you don't have all of the PCIe switch topologies that you would have in a Delta platform. In Delta, everything is basically on PCIe switches, whereas on Redstone, you have a direct link between the CPU, you have a PCIe Gen 4 by 16 link that goes to each GPU, and then all of the GPUs sit on this Redstone assembly that NVIDIA actually makes and sells. And so this NVIDIA assembly has NVLink between all the GPUs. So it's not a switch, like NV switch topology like we would have on the Delta platform. It's a direct connection between all the different GPUs on this. And since we sometimes get this question as well, no, you cannot mix the 40 gig or 80 gig modules or the 400 watt, 500 watt. Everything has to be the exact same on this, because remember that this is sold as a Redstone platform directly from NVIDIA with all these GPUs already pre-assembled. Now, let's also face it, Dell is also selling these to its existing customer base. Now, if you're an existing Dell customer and you're trying to wonder like, hey, well, what does this really replace? Because this is an AMD system. They didn't really have that many AMD systems in the previous generation. That's totally right. Now, this is really the upgrade, or I guess the newer version of the Dell EMC PowerEdge C4140. The C4140 was really interesting. We're specifically going to talk about the SXM version of that, which was, I guess, kind of closest to this. That was actually a 1U platform, but you had 4 GPUs, you had 2 CPUs. It was super deep. So whereas the XE8545 is 810 millimeters, I think the C4140, I think was something like 962 or something like that millimeters. So it was a much deeper chassis. And one of the big challenges was like you had this like 1U chassis. It was basically too long for a lot of racks. So you had to make sure you had the right racks for that. It didn't fit in a lot of existing racks. So having that 4U chassis kind of really helps. You also get more performance between the A100s. You get way more cores because you're going from 28 cores maximum in Skylake Cascade Lake up to 64 cores per socket with the new AMD EPYC. So you're getting way more performance in terms of CPU. So you get more GPU, CPU performance, but you have to go up to 4U. Now, some people are going to be like, oh, but that's like 4 times the footprint. I mean, I don't want that 4 times the footprint. But the fact of the matter is, like, let's kind of get real here. If you have a 2 kilowatt, say, per U system, right? And if you put 40U of that and you're doing 2 kilowatts per U, like you could do with a 4140, you basically end up with like 80 kilowatts plus per rack, because you have networking usually as well. So you're talking about like 80 plus kilowatts racks, and you know, you need deep racks and like high power racks, and like just most setups can't really cool that and can't really power that. And so I actually think that the 4U, going to 4U and having, maybe sure it takes up a little bit more rack space, but on the other hand, it tends to, I guess, be used more efficiently. I think that's perfectly okay. The other thing that you get with the XE8545 that you didn't really get with this C4140 is that you actually get front NVMe storage, and you get PCIe Gen 4 in the entire system. So these are actually just giant upgrades. I mean, this is a huge upgrade over the previous generation. Let's just call it what it is. And oh, by the way, just a little fun thing on Codenames. We talked about the Redstone platform, as that's the for NVIDIA A100 platform, but this overall platform, the codename inside Dell, I heard, was Marzal, Marzal, which also was a codename for a Lamborghini concept car. Now you might be wondering, like, hey, why do we need a codename for this? Why can't we just call it the XE8545? And you know, you have, I guess, Redstone, all okay, sure, but like why do we need all these codenames? But Dell actually codenames like almost everything, especially on the reusable components front. I'll give you another example, just a quick one. That 1U, I guess, drive, so a 10 drive 1U backplane that's used in this system is also used in some of Dell's other servers. And that little code name is actually called Reventon. Hopefully I don't get in trouble for saying that, but if I do, oh well. Now Dell has actually submitted this since we started doing the review in MLPerf training, so there are actually official results in terms of AI training, and I think those are really good if you just kind of want to look at that. And of course you have 4 GPUs, and we actually don't really have that many 4 GPU Redstone platforms, because most people have only wanted us to go review the, you know, Delta platforms or the PCIe platforms. So we haven't really done actually that many Redstone platforms, because usually just kind of people want one of those extremes for us to go review. And so we don't really have a great comparison set. And so we're just gonna say, maybe you should just go look at the MLPerf results for that. The one thing I would say is that if you are looking for like the maximum AI training performance, most of the big organizations that are doing AI training are really looking at the Delta platform with the 8 GPUs and the NV switch. And so that's just kind of a different architecture. My guess is that although Dell doesn't have a PowerEdge that really has that, they have that DSS system, this PCIe system, but they don't really have a PowerEdge system that has those 8 GPUs. But they're so common in the industry with other vendors that Dell probably has a partner that they can go get one from if you really want it. I do want to make one quick note on something that most people might not know actually about the system, but it is really important to just understand what Dell is doing. Now, Dell has the 400 watt 40 gig and the 500 watt 80 gig NVIDIA A100 SXM4 GPUs in this server. What's more, they're actually in the server air cooled, so you do not need to go to liquid cooling, and you can still run the 500 watt 80 gigabyte GPUs here, which is actually a really cool capability. There are some vendors, and actually quite a few vendors, that say, hey, you know, if you are going to go up to 500 watts per GPU in that 80 gig configuration, it is a good idea to just go liquid cooling immediately. But Dell has basically, by building this kind of crazy crunched up server, you know, they actually have the ability to still air cool both the, you know, 400 and 500 watt GPUs. The big caveat here though is that if you're using the 400 watt GPUs, your data center ambient temps can go up to 35 degrees centigrade, which is pretty darn good. The C4140 had some very, very narrow temperature bands. You actually had to kind of keep your data center pretty cool to be able to cool those things, because they were, you know, 1U chassis, and you know, you're definitely making a lot more trade-offs than you're making in this generation. But if you do go to the 80 gigabyte 500 watt NVIDIA A100 GPUs, that means that you have to keep your data center at 28 degrees centigrade and below. At STH, we keep our lab at like 27.2, 27.3. Usually the data center is running somewhere in that range. Sometimes we get down to like 27.1, but that's like pretty typical of what we run our data center at. And we're basically right on the edge of, if we did have the 500 watt GPU version, which we don't, but if we did have the 500 watt GPU version, I mean, for lack of better words, we basically right on the edge of like where we could actually cool those 500 watt GPUs. Now, the, of course, answer to that is that you just need to make sure that your data center temperatures stay lower, you know, so you stay below that 28 degrees centigrade. But if you are in a co-location facility, or maybe you don't have the cooling to be able to do that, that could be a challenge. So just something to keep in mind, the 500 watt GPUs are much faster. We proved that out when we did the Supermicro air versus liquid cooling piece, that we actually got really great performance from the 500 watt, 80 gig models, but at the same time, you do need to think about thermals if you're gonna use them. And before we get to our closeout on this, let's just kind of talk about the really important bit for a lot of buyers of the system, and that's just the fact that this does use Dell iDRAC. So you can use OpenManage to go manage these systems. It's all integrated, and so that's kind of, I guess, a big, draw of a system like this, right? You could go buy a system from another vendor, but if you're running your entire organization using OpenManage and you want to get GPUs and specifically S6M4 GPUs into that OpenManage environment, you're most likely going to end up buying this system because, well, that kind of fits in with your entire management ethos for your data center. I think I may have just coined using that. I don't think I've ever heard anybody say that. But the basic idea is that this is, iDRAC. It's managed like any other PowerEdge server, and it can be managed as part of a fleet of PowerEdge servers. So if you have all of your automation with PowerEdge, then hey, this is actually something that's easy to integrate into your environment. And given that, this is really a server that is designed to kind of take out that C4140 installations that you may have had for a couple years with the Volta generation of GPUs and also the Intel Xeon generation of processors. Now, these systems do use way more power. That is what it is. You have a total of 4 2.4 kilowatt power supplies versus dual 2.4. I think there's a lower power option too, but power supplies on the C4140. So you get twice as many power supplies, which means you need a couple more PDU ports. That's okay. You also move from a 1U to a 4U chassis. Again, I think the density on just how much power these things use, you're not gonna really fill up most racks. So that kind of makes the big change, and that funky rear end and kind of the quashing of the two servers that we saw on this kind of makes it all the more important because we have an 810 millimeter server versus a 962 millimeter server with the C4140. So we can use the standard racks rather than having to go to the giant deep racks. Overall, this thing is an absolutely super cool server. It's one of the first ones that we saw with Redstone, which is why this thing has been making cameos all the time in STH. I mean, I think this thing has made something like cameos in over 10 pieces over the last little bit. So it's definitely something that I've really wanted to go get out, but we've just been frankly constrained a little bit just with, folks and, resources to go get stuff done. And then also just the fact that we're doing this giant move. I think, it's just been a little bit rough. Hopefully you'll have noticed that this is hopefully getting a little bit better in terms of audio versus the last video. Don't know, but this is going to be the new studio. We're still building it out, as you can see, but this is going to be the new studio for, I guess, the rest of 2021 as it gets built out. And this also might be the last piece or last video that we do where you see some of the old STH Blue Door studio, because this is kind of being done in that transition period. Hey guys, I hope you liked this video. If you did, why don't you give it a like, click subscribe, turn on notifications so you can see whenever we come out with great new videos. As always, thanks for watching. Have an awesome day.